Okay, so talking about Top Hat, you can follow along on a tablet or something like that. That may be fun for you. But a lot of people still want to take handwritten notes, and so PChem, they were asking me, can we also get those PDFs of the notes 2 per page on Blackboard? And so I will say yes to that. So I will still on Blackboard put up the handouts, the PDF handouts for class if you want to print those. Now go to the computer lab to print those because your student, computer use fee, one of the many fees that you pay, is paying for all that paper and ink. Okay, so don't print on your own ink and paper at home because you've already bought a ton of paper and a ton of ink. So I'll get those notes up ahead of time, long enough that like hopefully a week ahead, I'll stay a week ahead. So you can always print, say, the next week's notes, 3-hole punch them, put them in a 2-inch binder, and then you can tab them and take notes that way. But when it comes time for a question, then you can pull up your phone or whatever, and you can answer the questions that we have. We're going to test drive Top Hat this morning and have a few questions related to sort of this introduction to forensic chemistry, and then you'll get to see how it goes. Okay, let's see. Now, let's talk a little bit about absences too. This Top Hat system is going to be how I track attendance and class participation. The answers will be displayed up here anonymously, but on the back end, I can see what you answered and so on. And so I can see if you're catching what I'm throwing out there. Okay. Now, it's not because we're still in this COVID situation. There's going to be chances that people will be absent for extended periods of time, maybe missing 2 consecutive lectures. So I'll still post the videos and not penalize you for missing class. You just won't be in that participation, report from my end. And so how to encourage participation? That was my question, right? If I require it for attendance, then I've got to figure out how to merge that attendance report with the grade book and everything. And I've got to take account documentation for COVID or just the regular 3 absences that the university allows you. And it starts to take hours and hours and hours of my time for like 5% of your grade. As I'm going to spend hours and hours of my time, it needs to be for a chunk, a more important chunk of your grade. So what I decided to do was all of this Top Hat participation and everything will be an average percentage at the end of the semester. And then that will just go in for your lowest homework quiz grade. And lowest will probably not be very low if you remember to do it that week. It'll be that time when you forgot to submit it and you got a 0, right? So this will be a way to erase one of those forgets, and that way, your participation. We have like 30 lectures, and so if you miss one or whatever lecture, that's 1/30 of 100%. So that's almost nothing, right? So you probably should have a good percentage of participation, and then that can wipe out one of those homework 0s. Okay, so that'll encourage participation without creating a whole bunch of paperwork. Okay, so that's good. Now, if you are sick, let's go to Blackboard. I'm going to tab over there. Let's see. Let me escape here. If you'll notice here, when you go into Blackboard, you get this this announcement that pops up. Don't just immediately, like I do instinctively, bail out of that, but read it. And this is if you don't have a doctor's note, like you just know you had COVID because you had all the symptoms and you stayed at home and slept for 2 days or what have you, you can still get documentation. This is an absence request notification form. And so they're wanting us to, if we're going to count attendance at all, and I'm counting attendance through Top Hat, go ahead and fill out this form. And you send it over to what used to be called the Dean of Students office. It's the Student Advocacy office, and they will do whatever they do, and I'll get a notification or something like that. So that's how we'll take care of COVID absences, is this form, unless you have a doctor's note or something like that. If you go in and get an official medical recognition that you had COVID, that's fine. Just shoot me a PDF of something like that. Okay, great. Now, I've made a few changes to the Blackboard site that will make it much more enjoyable for you. We still have everything in a weekly schedule. So here's our weekly schedule. Here's all of the lectures and all the quizzes and some things related to this control charting exercise that we're going to be doing. And then you get into week 1, week 2. Now, a lot of these are hidden from you. They'll show up as we get closer to each of those weeks. but I've added in here, what you need to do for this week. Class time, here's the notes for Thursday, notes for today. Here's the homework printout, and then some information about this control charting activity. Now, what you'll do is you'll follow this link to this shared Excel file. And you should have edit capabilities with that link. If you don't, then we'll figure it out. And on this is where you'll pick what you're going to use for your control chart data. We'll talk about that in a little bit. But what you're going to do the whole semester is track a data source and see what the normal variability is in that data source. And there's almost always going to be something that knocks it out of control. So this is a control charting exercise. And the thing is, you need to pick a data source that's going to be in control the whole semester. So that's why I have to approve it, because you may pick something that's going to trend as we go into spring. Like if you're picking daily temperature, it might be somewhat random for a couple of days or weeks, but it's going to eventually get warmer. And so that's not going to be in control. So a control set of data is going to be unchanging over time. And if there is a significant change, it's out of control. And so if you have a trending data, then that's not in control. But you can do daily differences. So temperature is a good one if you do today's temperature minus yesterday's temperature. And so that should be 0 if everything's perfectly the same every day. If we have a cold front, it'll drop, right? And it'll be negative. But then the next day it'll probably warm up, because this is Huntsville and that's what it does. Okay. And so then it'll come back into control. So we've had people use all kinds of things. Here's the second tab on this spreadsheet. It says good ideas from the past. And so you can click on here, and there's a lot of daily differences in high temperature, low temperature, percent relative humidity, atmospheric temperature, pressure, stocks. So some people track stocks. And it's been enjoyable sometimes to see what goes on with stocks. We had a student tracking Yamaha stock, and it was, in control, and then all of a sudden it went wildly out of control, and then it disappeared for 2 weeks. What happened, right? Well, everybody knew what happened. That was the tsunami and the nuclear plants shut down and everything in Japan, and the volatility of the stock went crazy, and then it shut down. So, if that was your only measure, like you didn't have any access to the news, you would have known something happened in Japan, right? And so that's the idea, is to track your data and to see if there was a significant event that happened. Okay. Also, daily step count using Fitbit or fitness app, that's valid too. Screen time, using a screen time measurement on your phone or something like that. So those are all good. So you can pick one of those, put what your idea is going to be here. I'll comment on it and then give you a yes or no, yes or not yet. Comment. But you have to have a yes in this column before you have approval to start collecting data. Okay. So that's on Blackboard on week 1. Here's the little link. Then you have the homework quiz, and then I've added these little navigation buttons down at the bottom. So you don't have to go back to the weekly thing. You can jump straight to week 2, and you can, if you go to week 2, you come down and you can go back to week 1. Like if you're trying to find the homework submission link or something like that, you can jump from week to week to week. So very proud of that. It's just navigation, but still, I was putting all of these homework tests and everything, and I was wanting to jump from week to week to week, and I was like, look, I'm going to make my life easy, and it'll make yours too. Okay, so that's a little bit of the details on Blackboard. Now, if you ever need to refer back to the syllabus, like for homework percentages or something like that, it's always right here on the syllabus item, and so that's good. Now, the lectures, if you'll notice on the weekly schedule, week 1, there's a link here to Top Hat. So if you're in Blackboard, you can hit this. There's one of these links in every one of the weekly things. So this will shoot you to Top Hat, to our class, where you can log in the morning and get to that. Or you can, if you have the app, you can go straight to it. Okay, so here we are. So let's dive in. So what is forensic chemistry? Well, it's going to be applied analytical. So we developed this degree about 15 or so years ago, and it was right after this huge boom in interest in forensic science. Do you know what caused that? Do you have any idea what caused this huge boom in interest in forensic science? Yeah.
Yeah, the TV
Yeah, crime scene investigators, CSI. Yeah, CSI Las Vegas, I think was the first one. Oh man, it really caused a lot of interest. We were pretty excited about that as chemists in general because uh, chemistry, can have a bad rap, right? Every time there's a large release of chemicals or something, it's probably related to some chemical industry. And so people think, chemistry bad. And then here with CSI, chemists were the problem solvers. They were the investigators. They a lot of times that they had of course the people going out with the badges and the guns, but they also had the lab folks. And so that's in sort of capturing that interest, we doubled our majors with this degree. And one of the things that we wanted to do was not just grab a degree program to capture that interest. We wanted to make sure that it was an employable degree. We had learned from the environmental science program earlier, because that was big in the 70s and 80s and 90s, still big, but there was a big sort of push for environmental science degrees. The environmental science program that they made had 2 geology courses and 2 chemistry courses and 2 biology courses, and we sadly were saying that they were graduating sophomores. They had a little bit of a knowledge in a whole lot of little things, but they weren't experts in any one thing. And so we did not want to go that route. We wanted to say that these folks getting a forensic chemistry degree are analytical chemists. Okay. And that's what your degree is. It's analytical chemistry. And so you can get a job in an analytical lab that can be any, like a water quality lab or any of these other kinds of labs, because instrumental analysis, all of the things that an analytical chemist knows. And you also have this forensic minor and this forensic chemistry course that sort of fills out some of the gaps in a traditional chemistry degree program. So that's what we wanted to do. And a forensic chemistry or an applied analytical person will have qualitative skills, which answers that question, what is it? And quantitative skills, which answers the questions, how much is it? And then we add in the statistics part for the how sure are you? Okay. Now for forensics, though, we really developed the art and skill and science of comparison. So in an analytical chemist, they may not necessarily be as interested in comparison, but in a forensic situation, you typically have an evidential piece, and you're trying to compare that evidence to something else. You've got the scene and you've got the accused, and you want to compare those things. So there's a lot of comparisons, and if they don't match, you're essentially done in a forensic setting. In an analytical setting, you may go further than that. But in a forensic setting, once you say they do or don't match, you write your report, and you're done. So this sort of funnel, we identify things, we classify them, and then if we can, we individualize them. There's another piece, though, that complicates things. If you'll notice the picture here, we have science is the hand, and it can do lots of things, but it is restricted in the forensic setting by the legal requirements. So you can't just go off and start doing some method that you thought up in your head on evidence, because it doesn't have a pedigree. And so we'll talk about that some more this morning. So we have to focus a lot on quality in this course. So that's going to be shoring up some of the statistics that you've already had in quant, specifically where you did standard deviation and means and so on. We're going to add in confidence intervals some more in this course, and the decision-making process. So we're going to focus on high-quality standards, and then we're really in the chemistry side of things. We're not doing the toxicology, although we have a little section I call baby tox, and we'll talk a little bit about the body and how things come into the body and how they're distributed and how they're eliminated. But it's just a very surface level of toxicology. We don't get into metabolism or anything, and we don't cover DNA, bloods, or fluids, or hair, or anything like that. We talk a little bit about fiber evidence, but it's from a physical standpoint. And so we're focused on the trace analysis in this course and the physical evidence properties. So this is our graphical syllabus. It's available on Blackboard. And so these are 3 parts of the course. We have the statistics and quality control, the chemical evidence, so looking at things where you get drilled down into the chemical structures, pH of something, the pKa's, and then the physical evidence. What are the physical properties of it? What's its shape? What's its color? What's its properties? So those are the 3 parts of the course. We have 4 exams that it's kind of, I don't really know how to avoid this. We have 3 parts of the course. So I have 3 exams, and then we have the final. So that last exam and the final, it's like half your exam average is in the last week of the course, right? So what I do to sort of give you and that's also your seniors, right? That's the time you're least motivated. Like you're looking at the sunrise, or the sunset. You're like ready to go. So what I do is after that 3rd exam, I'll grade it. I'll put up the tentative letter grade, and if you're like, hey, I'm good, you don't have to take the final. Okay. So that's always nice. And that's sort of a little gift to you as a senior. It's like your graduation gift. But if you're like, dang, I'm 2 points from the next letter grade, and if I make an 85 or something on the final, then I can bump up. And so then you can take the final. It can hurt you, though. I'm not going to say it's only helps, but because I want you to study and really, really attack it, if you're going to do it. Okay. But I'll be here on the final day. If you're here, we're good. But if you're not, I'll just take the grade that you have, and we're great. All right. Then homeworks are due Saturday nights. The reason I do that is not because I want you to work on Saturdays. I'd love for you to submit everything by Friday. You get to choose when you submit it. But a lot of people with their work schedules enjoy like a day of weekend, to work on things. And so you submit your homework whenever, but it's, the material for that homework will be done Thursday morning. So you have from Thursday morning, like the stuff that I haven't covered on Tuesday, you're like, well, I'd love to finish the homework, but there's still stuff on here that I don't understand. We'll probably finish it out on Thursday, and then you'll have all of Thursday and all of Friday to finish your homework, get it submitted, and then you don't have to do anything on Saturday. Okay. I just shake my head when I see people, it's 11:59 on Saturday night, and they're like, I didn't get it turned in. I was like, you had all this time. So schedule your time. Now, this control charting activity, there's a midterm draft and a final report. This is a different kind of writing than PCHEM. Okay, these are what do we call them? We call them both reports, right? We call the PCHEM lab reports, and we call these reports. But the PCHEM reports, if I could change that name, those were more like articles. Right, you have an introduction, a theory, and all that stuff. That's like an article introducing the material, telling them what you did, the results, discussion, and all of that stuff. This is more like a report, like a standardized report. Okay, so you will, I'll put up some examples of what these look like, and this is not supposed to be super creative. This is supposed to just tell the facts of what you're tracking. Here's where I got the data. Here's how I performed over time. Here are my conclusions. Here's when it went out of control, and it should be very lean and clean. And so I will grade that midterm report, and I will give you feedback, and then you'll do a comment response table for your final report. You'll clean up all of the things that I point out. You'll give me a comment response table where you say, here's what you said, here's how I fixed it, here's the page and line number where that fix is implemented. And that's, again, just to reinforce that skill. If you do get comments, go ahead, if it's a peer-reviewed type thing, go ahead and respond to every one of those comments and show them where you changed your work. So this first part of the course, it's a matter of trust, statistics and quality control. We want to have trust in our criminal justice system, don't we? And so we want to make sure that our instruments are calibrated, that our methods and procedures are documented, that our personnel are trained, so that you have a pedigree of getting good results, and that everything is rock solid, that you won't be the question at the trial, right? You don't want your work to be questioned. Your work should be rock solid and trustworthy, and then everybody can essentially use that work to make their case, whatever that case is, either prosecution or defense. It doesn't matter, okay? But you want to have reliable results so that they can trust everything that you've done. So to do that, we get into mostly the statistics and analyzing the statistics. So here's some key forensic and legal concepts. So this evidence that's produced by your scientific analysis is admissible to the court, and this is those restrictions, those legal requirements that we put on science, if those techniques are accepted by the relevant scientific community. Yeah, so go ahead and write that down, that first bullet point. And so this is the big question, admissibility. Is it trustworthy enough to go into the courtroom? That's your question. So how would we decide that a GCMS result is admissible in the courtroom? There's a lot of moving parts. I mean, the GCMS is a very complicated piece of equipment, and the procedure is difficult, and so on. What makes it admissible? And what makes it admissible is that second bullet point. It can be established in the peer-reviewed literature. So the literature shows that this is a reliable technique, that you put the same thing in, you get the same results out. And there are several journals out there that can establish, the performance of these different kinds of scientific analyses. So you can look up those. But this is the Fry rule. So make sure that you circle that or clearly label the Fry rule is that admissibility is based upon that peer-reviewed literature by the relevant scientific community. And so here are some relevant scientific communities. Look at that. If you have this on your notes, you can zoom in and see all of these different scientific. They used to be called scientific working groups. Now they're the scientific area committees, and it's managed by NIST. It was independent. Now it's all been collected under the National Institutes of Science Standards and Technology, and it's pretty amazing. So we have biological data. So we have data interpretation and reporting, biological methods, and even wildlife forensics. So there's a whole committee on wildlife forensics. Pretty interesting. Then we have the chemical and instrumental analysis, so gunshot residue, seized drugs, toxicology, trace materials, fire debris, and explosives. We're going to talk about almost all of those in this course. Pattern recognition, so blood stain pattern, footwear and tire, friction ridge, fingerprints. So there's a whole committee on those things. And so that committee would evaluate new techniques and, publish a report. And then you would refer to that if you're wanting to use one of those techniques and your opponent in the courtroom said, well, where has this been accepted before in the scientific community? You could refer to these organizations and these scientific area committees and say, these are the recommendations put forward by these committees. Okay, we saw one recently, this digital evidence right here under the digital multimedia. So did anybody follow the Kyle Rittenhouse trial? Did anybody follow that? Did you notice that on discovery, the prosecution had a video? They were going to try to make the case that Kyle was pointing the gun at a bunch of people, and they had video evidence that they thought pointed that out. And under discovery, they gave you have to give the evidence to your opponent so they can see what evidence you have, and vice versa. And so they gave them a much lower resolution video. So they totally violated what would be the recommendations of this digital evidence. They didn't provide the highest resolution video that they were going to be using in their argument. And think of what that could have done to the defense if that was a key piece of evidence. Because the defense looks at this low resolution video and they say they can't make a case with this, so we don't have to worry about it. And then you get to the courtroom and they show this 4K video, which they didn't, but I'm saying they could have shown this really high resolution video that made the case, and now the defense is caught on their back foot. So even digital evidence, and probably even more so now with all the video everywhere, this is a really important committee. So I think that's an interesting example. And so that would be one of those things where they could make the case to the judge of what they were delivered and what the prosecution had, and the judge could say this is not admissible because of the way it was handled. And we'll see why the judge gets to say in the next case. So the Daubert decision is, again, these rules of evidence. The judge has a gatekeeper role. Okay, for admissibility. So in that situation, the defense could object. They could send the jury out. and the judge could evaluate what happened with this digital evidence, and the judge is the gatekeeper. And so the judge can say, this evidence will not show up in this trial. And so now, of course, if it's a scientific, I wrote these notes thinking from the perspective of like a new scientific analysis. So those kinds of things like error rate or peer review would be used by the judge. But in this case of the video evidence, it would be the resolution that the prosecution had versus the resolution that the defense had, and so on. So the judge can make a decision on any one of those factors. So this Daubert decision, that's the main point. It put the judge in the gatekeeper role. The Frye rule is the scientific community would support admissibility or not. And so that brought in the scientific community and these scientific working groups. And then the Daubert decision put the judge as the final arbiter in as far as what's admissible for evidence. But it's still using scientific evidence, right? What about expert testimony? Okay, that's the Kumo decision. So the Kumo decision extended gatekeeping to expert testimony as well. So you need to attach Kumo to expert testimony. So these three rulings will be important throughout the course, and they'll be on the first exam and on the final for sure, and in the homeworks.
So the Daubert is just for like scientific evidence?
Yeah, it was mainly set up for scientific evidence.
And then the Kumo did send
all of it, yeah, expert testimony. So what kind of experts would be out there in terms of expert testimony? Well, you bring an expert, maybe a psychologist, maybe a forensic psychologist, or an arson investigator or something like that. Someone who's going to give their expert testimony. Now, what kind of things would the judge use to evaluate whether this arson investigator is admissible, like their testimony is admissible? Well, their degrees or their training or their certifications, are they part of the Arson Investigators Society? Do they have certifications for that? So the judge would look at the person's credentials to see if they would be a reliable expert or not.
So does the judge just judge off of what they think is credible, or is there basically like a whole book of like what?
That I don't know. I don't know sort of how much guidance the judge has in terms of how they evaluate. But that's why there's so many societies for these different things. You would want to have some sort of standardization, like for the arson investigators. Where do they get training, and how recent is their training, and have they given testimony before, and those kinds of things. So each discipline will have its own standards and certifications and trainings. But these are part of that glove, right, that restricts the scientific community in its application to forensics. And so let's do our first question. So this is our first top hat question. And so the testimony of an arson investigator will be evaluated for admissibility according to which precedential ruling? You probably need some more time. Maybe 15 seconds. Okay, I can bump it up there. I hate timers. Even as a little kid, I watched this hourglass and it's going down. Okay, very good. All right, let's see how we did. All right, so it's Kumo. So the key in this text of this question would be to recognize that the arson investigator would be an expert testimony person, and so the expert testimony admissibility is under that Kumo decision that extended Daubert into expert testimony. Okay, so there's other kinds of things that we need to consider in terms of our forensic concepts, and that is direct versus indirect evidence. So there's really all of evidence can be put into those two categories. And direct evidence is really a small category. That's eyewitness testimony. I saw this person do what they're accused of doing, or I saw them at the bar with me. They couldn't have been there doing what you accused them of doing. Eyewitness testimony is its own kind of evidence, and then everything else is indirect evidence, which requires inference and logic. Okay. And many prosecutors would prefer to have indirect evidence because they feel like they can make a stronger case. Now, in the past, this indirect evidence had the name circumstantial evidence, and people always thought that was like almost a pejorative, like it made it seem like, oh, it was just a circumstance that my cigarette was found with my DNA in the victim's house. No, but that's indirect evidence. But the judges they instruct the juries to give no difference in weight. So just because you don't have eyewitness testimony, the indirect evidence should be given just as much weight as the direct evidence. And a forensic scientist is going to be dealing 100% with indirect evidence. You're not going to take the witnesses in and, subject them to chemical tests. No, so you're going to be dealing with indirect evidence. It requires inference and logic, but this is nice because you can back away and not have any emotional connection to what you're working with and what you're analyzing. And so it's a really, I think, emotionally, for me, it's emotionally comforting to know I'm just focused on what the chemicals are telling me or what the physical properties are telling me. And I write my report. I'm not invested in personalities, right? I'm not dealing with witnesses. I'm not dealing with anything like that. And so I think it's a very, for me, very comforting to know that I can just deal with the logic of the situation. Other factors are destructive versus non-destructive testing. So this is always something to consider. If you have that one fiber that is the one piece of evidence that seems really important, you've only got one. Now, you don't know what the case is necessarily, but in this evidence bag, you only have one hair. You're probably not going to dissolve it in nitric acid and look for trace metals because you just destroyed the one hair. Now, if you can chop a little bit out and send it off for DNA or something like that, that's still destructive, but it's only a small piece. Okay. So it's just how much of that sample will be destroyed. And we'll talk about sampling plans in this course. And then for the homework, this chain of custody, I asked a question or two about that. This is probably the most important piece. So you have to become a very meticulous person. And that's part of the control charting exercise, is you're supposed to track something daily. So that means you need to develop habits. And the chain of custody is the most important habit. You have check out the evidence. It's in your name. You are the custodian of that evidence. And so it needs to be locked up. It needs to be reported. And you need to put it back in the evidence locker, and you need to sign everything out. You've got to be so meticulous on that, because if you break the chain of custody, then you've ruined the case. Now, again, we don't care what that case is, but both sides are important. It could be the prosecution case coming at someone who's a villain, right? Or it could be the exoneration of someone who's innocent. Both sides are important, and you don't want to wreck those cases with something sloppy like leaving evidence on your desk when you go to lunch and you come back and it's gone because somebody moved it around and maybe they checked it back in for you, and you can't account for it for a small period of time, and that's enough to break the chain of custody. Is that going to make it to the courtroom? Maybe not. You don't know. But what will happen is you'll have a large temptation at that point, because you were sloppy, to lie and to not admit you were wrong or that you made a mistake. And so that's where the ethical things come in, and it gets really difficult. If you're sloppy, then you start trying to cover it up. It's just human nature. And so the more meticulous you are, the less temptation there is to ever have an ethical issue, right? So that's chain of custody is huge. So that's the matter of trust. You want them to trust your results and you trust your evidence handling skills, and so you can't ever break that trust. Now we get into the chemical evidence. And so most of the time you're dealing with, you may have a general unknown as part of evidence. You had presumptive tests, which we get into those like spot tests, color changes for drugs and so on. Then you maybe have some screening tests, extractions, liquid extraction. We talk about that. It's a huge part of the course. And then we get into the instrumental analysis, so confirmation tests. And under the working group for drugs, they say that they have these categories A, B, and C. And for you to you can have like A is the strongest, like instrumental analysis, an FTIR, a gas chromatograph, a mass spec. Those are so tied to the molecular structure of that substance. It's hard to fool those. Okay. And so if you have two category A, like you have an IR of the drug and you have even a gas chromatograph of the drug or a liquid chromatograph of the drug, and it comes out at the right retention time, and you have an IR that says it's heroin, then that's enough to say it's heroin. You write your report. So you have two category A's. You can have a category A, B, and C. So if it's a spot test and it's in the right phase and you get a FTIR, then that's enough, again, to say that it's drug. So they have these recommendations to say we have two category A analyses or an A, B, and a C, then we can make the report and say, yes, we have a high confidence that this is heroin. Okay. So this brings in instrumental analysis. So let's do our second question. Come on. Now this one's a typing, so you have to type on your phones. What instrumental methods do you think would be useful in a forensic laboratory? I mainly put this, we're test driving Top Hat. I want to see what a typed question looks like. So I've never done this because I didn't have a classroom until now. So now I have students. You guys can type in your things. You can use acronyms or abbreviations. You don't have to. So I'm going to start the question and you get to type in. So I don't know what we're going to see. So I didn't set any correct answers, so we'll just see what we get. And I don't know if we get a word list or something. I was kind of hoping for a word cloud, like if a bunch of people put FTIR, that it would be really big. But I don't think that's going to happen. Oh. So think back to instrumental analysis, right? So, and y'all can talk. What did you put? Yeah. Okay. They don't have to be long, but you guys text so fast. I'm sure you could write like War and Peace in 30 seconds. For me, it's like F, T. My daughter laughs at me. Okay, I'm gonna let time run out, so it's not a problem if you didn't get it in. Okay, so let's move on. Okay, FTIR, everybody listen to me. So yeah, so we've got a nice little word list. These are all, again, so here's FTIR again. I don't know why it didn't catch, maybe there's a space in there. Chromatography, GCMS, yay. All right, very good. Yeah. All right. So that's what we get, is a list of words. But we can kind of see a little bit of a histogram there. Nice. Okay, and then we get into physical evidence. So at the top level, we were asking, are you trustworthy? And then in the middle level for trace analysis, I mean, we're dealing with nanograms of material, maybe even picograms of material, 10 to the minus 12. That would be probably a detection limit. Are you competent enough to analyze those things? And are you a chemist, right? Do you understand chemical formulas? And can you know when this is an acid or when this is a base, right? But then with physical evidence, are you observant? Right, so that's, again, are you an observant analyst? One of the embarrassing mistakes that some chemists, forensic chemists, do is they focus only on the chemistry, right? And so you got two fibers, one from the victim, one from this other evidence from off the coat of a suspect, and you go to the FTIR and you put this fiber under the FTIR and you tighten down the ATR and you get a spectrum, and it's a polyester nylon blend, okay? And you got this nice little peak. And then you take the other fiber and you do the same exact thing, and you get a polyester nylon blend, and you go, these fibers are the same, right? Same chemical structure. But then you look at them, and if you're not observant, you look at them and you see they may be made of the same stuff, but they're not the same fiber. So physical properties are just as important. Embarrassing situations would be they're chemically the same, but they're different colors. Right? Like, did you even look at them? I mean, if you were on the stand and you said they were, and I was cross-examining, it's like, did you even look at the evidence? And the jury is going to say, no, this is ridiculous. You know, so all of that is out the window, and you are totally embarrassed, and it's a disaster. Okay, so hopefully that would be caught before it was ever in the courtroom. But yeah, physical properties are really important too, and that's what we see. Oh, what's going on? Oh, this weather thing. I can't get rid of that. Okay, so looking at fibers, looking at gunshot residue analysis, where we get into microscopy and looking at the shapes of particles. Pollen and gunshot residue are the same size. So it's going to be really hard to find that, needle in a haystack, maybe, but you have a scanning electron microscope that can definitely see the difference very easily. And the gunshot residue is a molten particle, so it looks smooth on the outside, whereas pollen has all these little spikes, so it can stick to stuff and move around and get caught on the wind and everything like that and irritate your nose. Okay, so the physical evidence is sort of a really key piece. And then, of course, we have the homework quizzes, and we have the control charting. So let's talk about the control charting a little bit. So this purpose of this exercise, and this will be in every one of your reports. Essentially, you can copy these words. I mean, you'll have the notes, so you don't have to write them down now. But these are the purposes of this exercise. I want you to learn about continuously variable data. So that doesn't mean that the data changes continuously. It means that you have essentially a ton of decimal places that go up and down, as opposed to digitized rounded data. So look at the gas prices, right? It's rounded to the third decimal place. You see that little 9 on there? That 9 is always there. So that digit never changes. It's always a 9. And the next 2 digits change, but they don't change daily. There might be several days when it's the same price, and then it goes up 5 cents or whatever, and then it stays there for a couple of days. That's really not continuously variable data. 1, it's rounded digitally, and 2, it doesn't change on a daily basis. And so we want to have data that is more variable than that. It has more decimal places that change all the time. So category data, like we'll see an example of that in a minute. So then I also want you to demonstrate the meticulous skill of monitoring a process daily. So let's say you're in a crime lab and you run GCMS and you want to make sure that that's behaving the same every day. What would you do? Maybe you have a check sample that you run every day. Before you begin analyzing evidence, you run your calibrations, and then you run a check sample of a known, say a heroin sample or a cocaine sample, and it comes out at the right spot. You could track that retention time and put that on a control chart. And then next day you put the next data point, next day you put the next data point. Third day, it's now all of a sudden missing, or, it's stuck in the instrument a lot longer. It was 30 seconds late coming out. Something's changed, right? Now, you only know it changed if you know how it behaves day after day. And so I want to develop you in that skill of doing this kind of meticulous work, collecting a data point every day. Now, we really don't have the ability to grab instruments for you guys to go just run a GC every day, but the idea is collecting something every day and getting into that habit. Okay. Now, why do we want to do that every day? Well, let's say your GC went out of control on Wednesday, but you didn't know it, because you check every week. And so then you run samples on Monday, ran samples on Tuesday. Those were fine. Wednesday, it went out of control. You ran samples on Wednesday because you didn't know it was out of control. Ran it on Thursday, ran them on Friday. Then Monday, you calibrate the instrument and you realize it's been out of control. You don't know when it went out of control. So you have to throw out all of the previous week's data back to Monday, because that's the last time it was in control. So you've put a question mark on that data, and you have to throw it out and redo it. So that's a problem of just not tracking that process daily. Now, it's for efficiency's sake, you need to pick that key process variable. You can't track everything daily. And so in a real situation, there may be one or two variables that you track that will affect the whole operation. And that way you track those two things. Like at Pantex, it was our balances. If their balances were doing well, everything else would be fine. And so they were tracking their balances. If the balances went out, then everything else is suspect. And so they would track their balances daily. Okay. And then this benefits of data-generated action in contrast to calendar-generated action. So a calendar-generated action would be, we're going to recalibrate, say, maybe every day, okay? Which is a lot of extra sample prep, a lot of extra time. What if you could just load the tray up and start running samples the next morning when you come in? And so data-generated action would be, you come in on Tuesday, it was calibrated on Monday, you come in on Tuesday, you run your check sample, it's right in the right spot. It's within control. You're free to operate now because you've still got the same calibration curve you ran yesterday. And so you're not going to recalibrate until the instrument tells you to. So you don't have to calibrate on Tuesday if your check sample hits. And then on Wednesday, your check sample hits. So you can run that day on the same calibration. So you're not wasting time doing all that. And so that's what we mean by data-generated action, not calendar-generated action. Okay. If you were calendar-generated, it was like you calibrate every morning, no matter what. And so you're blowing an hour a day, which really adds up. And not only that, you're introducing variability, because what if your Tuesday calibration was kind of wonky, because that's personal error. And so you're actually rocking the instrument unnecessarily. You get a really sweet calibration on Monday, and it's still in cal on Tuesday, Wednesday, Thursday, leave it, because that was a good cal and the instrument's still behaving well. Okay. So that's what we mean by data-generated action versus calendar-generated action. Calendar is just a schedule. You don't even think about the data. You just follow the schedule. And data-generated action was you use a control chart and you track the performance. And if the performance is still in control, you're free to act. Okay. So that's the three purposes of this control chart assignment. And so you just need to find a continuously variable data source. And so that's what that spreadsheet is for. So let's look at some control charts. This is a really good one. How do we know the performance of our data source? We have to have a training period or a learning period. And so for 15 days, we will collect data, and we won't calculate the standard deviation or anything until after those 15 days. So you collect data for 3 weeks, and then you know how your process changes. Like if you're doing your Fitbit app, and one day you would go 6,000 steps, then 5,000, and then you have a good day, 8,000, and so on. You've got your variability for 15 days, and that will set up your error bars of your normal activity. And then from that point forward, we draw the action line, the watch lines, and so on. So this is the mean of the training period. This is the first standard deviation, the second standard deviation, and so then we track it. And when it gets one standard deviation away from the mean, we call that a watch limit. So we're watching the data. If it goes out 2 standard deviations, we take action. Now in a GC or something, the action would be to recalibrate or investigate what's causing it to go out of control. But for your situation, you're just going to do some research online, or if you're tracking your steps, you're like, yeah, I had to park at Bowers again, walk all the way in, and then I forgot something, I had to walk back, and then I had to come back. So, you know the reason why you had so many extra steps, okay? But for like stocks or something, you go to Google Finance, and you had to look up, what happened. There was an earthquake and a tsunami. So every one of these actions, so in this particular student's case, they only had 4 events in their action log. And rarely, but occasionally, a student will go the whole semester and not have any events in their action log. So, it's not exactly exciting, but it is what it is. Okay. but almost everybody will have several events in their action log. Okay. Had a person tracking their daily difference in weight one time, and I don't like the kinds. I don't like personal information because I'm reading all these reports. I'd rather just not know, right? but they were tracking daily difference. I said that way you don't feel like you don't feel self-conscious or whatever. I don't know. And so then they went out of control low, like they lost a lot of weight. And so then I was curious, and they had gotten sick, like they had gotten the flu or something, and they had lost a lot of water weight and everything like that. And so they lost like 3 pounds or something in one day. And their little action log was like, yeah, I've been sick for a couple of days, and their little change went down, down, down. So it's kind of interesting. Okay. So when I say you must get my approval, again, I want to help you avoid data that's going to be bad. Okay. And trending data is going to be bad because it's going to go out of control and stay out of control the rest of the semester. Okay, so that's not cool. So these daily differences are good. So a daily change in temperature is good, whereas temperature is bad. So you take today's temperature minus yesterday, and it's important to get it correct like that, okay? Because we want, if today's temperature went down compared to yesterday, we want the sign to be negative, right? Because negative signs imply a drop, and a positive sign implies a rise. If you swap those two, then your signs will be opposites. And so it's always today minus the previous day. And so that's what we say. The previous day's temperature was subtracted from, okay? So that's important. If you're going to use from, this yesterday subtracted from today. So the language, the English grammar needs to match the equation. And I'll check that in your midterm reports, and I'll correct it if it's wrong. Okay, so let's look at some. So it's not yesterday minus today, it's today minus yesterday. And that works for stocks, for pressure, relative humidity, any of those examples. So what's wrong with this control chart? Yes, Phil.
There's too much difference. Crazy.
This is what I mean. Yeah, you got it. You identified it, but you're wondering how to describe it. This is that digitally rounded data. And this is what I mean when I say continuously variable data. This is not continuously variable. This is category data. And look, there's only 4 answers. You see that? So that's category data. That's like, excellent, good, fair, poor, and awful. So you got categories, and it's not valid to do statistics like standard deviations and so on category data. You have to use a whole different, it's not Gaussian statistics. So this would not work because we did statistics on it, and it looks like it's out of control almost 30% of the time, when it's really not out of control 30% of the time. What we have a problem with is our statistics, trying to analyze category data with continuously variable statistics. So we want to make sure we have a data source that has lots of decimal places that change all the time. So if you're going to do temperature, make sure you use a weather site that gives you, several decimal places. It doesn't just report 73, right? 73.5 or something like that is better. Okay. Daily average, where averages are going to have some decimal places, and so averages are good. And so that's digitally rounded data or category data. This is what's wrong with this chart. Yeah, trending. So a control chart shouldn't trend. It should be centered around 0 or so around some average value. If you're doing daily differences, it should be centered around 0 because it'll go up one day and down another. But if it's a step count, hopefully your active is 5,000, and that's your mean value plus or minus. And so that, but it should, most people are, in a regular, on a regular week or whatever, we'll hover around the mean. There'll be good days and bad days, and you might have a pretty wide band, but still you're going to have a behavior that you have, and there'll be 1 or 2 out of control points. You'll be sick and won't walk at all, and then you got a low point, and then you might. Now, if you have a lot of those in your training period, then you're going to have really wide error bars. Okay, but that's the way it is. That's what you have. All right, so this one is just to get to know you guys a little bit. Click on the part of the course you're most excited about. So this is a question type I'm really excited about because I like visual stuff. And so you can pick like the statistics or the chemical evidence or physical evidence. I just want to see, and it should register a click. So you can zoom in and click on it. I envision using this like having a pH scale and you got a molecule. It's like, what pH do you think this will be? pKa or something. So instead of like typing in a numerical answer, you can click on that, or organic phase or aqueous phase. Oh no, okay, yeah, all right. Okay, so let's see. This is what it shows. Oh, heat map. Man, you guys are hating on the statistics. I hope to win you over, okay? But now I know, right? My work's cut out for me in the first part of this course. Okay, so that's going to be good. All right, submission closed. All right, and we are at the end. Okay, so what I'm going to do at the end of this, it says in presentation, it says in and assign items to review. It makes it look like in Top Hat you have an assignment, but it's just making the slides available to you. So you can go back through Top Hat and see the questions that we answered and maybe the responses, I'm not sure. And so I'm going to assign that, and I'm going to go ahead and select all of the little quizzes that you guys can review, even though today there wasn't really, the quiz is more for like trying out the stuff.
So usually will those quizzes be like for grade, or is it just for like participation?
I get to choose whether I want to grade that thing or not, but I'll probably, because it's extra credit, I'm using the graded part sort of let me know if you're catching the material as it's happening in lecture, okay? But it'll probably I'll probably do a participation percentage. So like, did you log in and answer? Even if you got it wrong, that'll still be your percentage of the semester that you participated, and that will be your grade for participation. But I'm curious about the grade. I want to see who's getting it right and who's struggling. Okay. All right. Are there any other questions? Oh, yeah. Okay, so the book, right? This is, let's see, it's on the syllabus. Nope, it's in the weekly. This book, I really like the second edition of the Bell textbook. They asked me to review the third edition, so I was excited to see a third edition coming out, but it's not published yet. And the second edition went out of print. And so what do we do? Well, I looked at other kinds of forensics books. They're good too, but I used the Bell book to make all my notes, and I like it. And so we asked around, you asked the publisher and so on, and they gave us permission to distribute this PDF so that you guys can use this PDF in the course. And so here, this is the full book. And so you can pull it up, and there's everything. So, how to use it? Well, if we're talking about a particular topic, you can find that topic in the book and you can read more about it here. It's just really to supplement the notes. You could take the whole course from my notes, but the book is there to give you a deeper discussion on all of the different topics. Okay. So that's nice. And that'll, again, if you had to pay for the Top Hat individually because you're into the Bearcat bundle, at least you don't have to pay for the book. So that'll offset the difference.
When do we start the control chart?
Start now by this right here is your control chart exercise for now. So go in here and pick a data type, and go ahead and explore. Like if you want to, if you're say you're going to do a stock, where are you going to get that stock? You're going to go to Google Finance or Dow Jones or something like that. So have your URLs and everything. You can type a whole lot in this little box. So I don't expect just a one-word thing. Go ahead and tell me, I'm going to track Disney stock, and I'm going to get my information from Google Finance. And if there's ever a out of control point, I'm also going to go to Google News to see what happened with Disney. So type all of that in, and I'll say that's a great plan. I do the daily difference so that it doesn't trend, and you're good to go. So if you do daily difference of stock, that's going to be centered around 0. So pick something you're interested in. It doesn't have to be chemistry related. Like a Disney stock is totally fine. And then when they have the Book of Boba Fett or something like that is causing a bunch of new subscriptions, then we're good. Or if something they like get rid of Gina Carano and then they tank. So there are going to be all kinds of things that you can research with these kinds of data. All right, so that's it. Y'all have a great day.